Hello everyone, I Dr. Odhesh Kumar, Assistant Professor, Department of Computer Science, MMB, Banaras Hindu University. I welcome you all in this course titled Digital Logic and Circuit Simulation. In today's lecture, we will discuss about what is the meaning of sequential circuit, means basics of sequential circuit, in which first some previous lectures or first some previous presentation we already discussed about combinational circuit. And what is the generally combinational circuit are those circuit in which the output depends only on the present combination of input, only present values of input, not of past input. But here in case of sequential circuit, some memory elements are connected as a feedback path, and this means the output is a combination of present input as well as the some previous state or some previous elements which are stored in a memory. So, this means output is not only a function of present combination of input, but it also a function, means it also depends on some past inputs that are known as a previous states value, and then we will generate a next state as well as output. Here generally digital circuits are classified into two categories, combinational circuit and sequential circuit. The difference between both are, what is here in combinational circuits there are n number of inputs and m number of outputs, and here in case of a sequential circuit there are n number of inputs, m number of outputs, and there is some previous state, some memory elements that are connected in the form of feedback path. Combinational circuit, the output depends only on the present combination, but here means, and in case of combinational circuit, what are the logic gates are the fundamental building block of combinational circuit. But what happens here in case of sequential circuit, that is a consist of combinational circuit to which memory element are connected to form the feedback path. Here we see that these are the memory element are connected to form a feedback path, and that are taken as the input, and then we determine the value of output here. What is memory element now? Memory element are a device which are capable of storing binary information within them. Like as here, this is a memory element, so this means that is capable of storing information, bit of information. Each memory element store a bit of information, and the binary information stored in the memory element at any given time define the state of a sequential circuit. This means the binary information stored in memory element at any given time which defines the state of a sequential circuit. So, here there are two types of states generally when we store this is the previous stored value in a memory element, and then when these previous value is used as a input and some combination of present input, then finally we determine the what value after applying present combination of input and previous memory element value, then what will be generated the output as well as what values are updated, what are the updated values of memory element. The updated values of memory elements are known as a next state, and already previously used value of memory element that are known as a previous state. These are here that are previous states, and this means here that are the next state, these are next state. There are two type of outputs in case of sequential circuit. One is the output and another one is the what are the next stored, means how the memory elements are updated. Final outputs that depends on a inputs as well as previously stored states that are named as a previous states, and next state means that we also update updated value of a memory element that is known as a next state when we use some present input combination and previously stored value for generating a value of next state. Then this means it depends on the input as well as previously stored states value. This means what circuit sequential circuit consists of what inputs, internal states and output, while combinational circuit consists of only inputs and outputs. But in here this is additional, there is a internal states, means the some memory element connected in the form of feedback. Again sequential circuits are classified into two category. One is a synchronous sequential circuit and another one is a asynchronous sequential circuit. How we can differentiate between both, means what is the difference between synchronous sequential circuit and asynchronous sequential circuit. Let us take a sub example. Suppose this is a circuit. This circuit we see that when E is equal to 1 means this enable input is 1, then the output depends on the previous means present combination of input x, y as well as some previously stored value p and q, and when is equal to 0, then whatever the previously stored state, whatever the present combination of input, the output is unpredictable, means output is always 1 in that situation. When E is equal to 0, then output is always 1, whatever the value of x, y or p or q. So, when E is equal to 1, this means this circuit behaves like as a sequential circuit, and when E is equal to 0, this means the circuit always provides output 1, it not depends on the values of x, y and previous states p and q. This is another circuit. What happens here? The second input of this is taken as a output of this gate, and first input of this, and this is, suppose this is what, this is nothing but a, this is suppose this is R and this is S. What is this? This is Q, and this provides just a Q complement. What happens here? When in this circuit, if there is no enable input, then output changes immediately when B change the input. Suppose B change the input, then output immediately changes. So, when incidentally simply the value of inputs are changed, then immediately their outputs are also changed. But here suppose someone incidentally change, in this circuit someone incidentally change the value of x and y, then it not immediately, the output change is not reflected immediately. Why? Because this also depends on the enable input, means when enable input is 1 and anyone change the output x, y, then change is reflected. But when enable input is 0, whatever change done by incidentally or accidentally, this means the output is not reflected here. So, that is why here enable input is used for avoiding a accidentally change of the value of accidentally or intensely change of value of x, input x and y, because in case of asynchronous sequence, this is a type of asynchronous sequential circuit. This is also a type of asynchronous sequential circuit. Why? Because in case of asynchronous sequential circuit, the behavior of circuit depends upon the order in which the input signal changes and can be affected at any instant of time. So, simply at any instant of time when the inputs are changed, means the value of R and S are changed, that their output are also, means its changes are reflected immediately. Here what happens? In this case the change is also reflected, but this depends on the value of E. When E is equal to 1, then this depends on the value of x, y, and when anyone incidentally or accidentally change the value of x, y, then its change reflected. And whenever the value of E is equal to 0, the change not reflected and even it not functional, because whatever the value of x, y and previous state p, q, the output is same, that is 1. So, here in case of asynchronous sequential circuit, the behavior of asynchronous sequential circuit depends upon the order in which its input signal change and can be affected at any instant of time. Here in case of synchronous sequential circuit, the behavior can be defined from the knowledge of its signal at discrete instant of time. Means the behavior of circuit can be defined from the knowledge of its signal at discrete instant of time. So, let us suppose here this is a clock, this is a clock, and when the circuit, means when suppose any circuit, to when suppose clock is high. So, when the clock is high, means whatever, this is a one complete clock, this is a one complete clock cycle, that is named as a T. So, in a one complete cycle of clock, this sometimes means half of the time clock is high and half of the time clock is low. Similarly, here we see that this is another one complete of cycle. This means half of the time clock is low high and half of the time clock is low. In case when during a clock pulse, what once we provide a simply clock pulse is high and whatever provided as a input and simply whatever the output after that and it not change during the clock pulse. During the clock pulse the output remains same and after that it may be changed. Here the clock signals are used to control the behavior of a sequential circuit, means the synchronous sequential circuit works only and only when the clock pulse is high. The value of clock pulse Cp, that is denoted by Cp, and this is Cp is taken as a 1. So, here in case of E simply we take when this is Cp means when either the clock is high or the clock is low, then only the sequential circuit works, otherwise not. So, here storage element affected only when the arrival of each clock pulse. So, simply the storage element affected on the arrival, this is the first clock pulse, this is a second clock pulse, similarly third clock pulse. So, storage element when suppose this clock is completed and this clock occurs, then storage element whatever the value stored in a output or states, it not affected until this clock not complete. Similarly, whatever means change occurs after completing this clock and once this change happens, then it not change until the clock second clock is not completed and so on. So, here this is the main difference between synchronous sequential circuit and synchronous sequential circuit. It depends on a clock, and in case of a synchronous sequential circuit, clock signal are not used to control the operation of a sequential circuit. Then block diagram of synchronous sequential circuit. Here in case of synchronous sequential circuit there is a clock pulse. So, all the flip flop given a same clock pulse, like as a in case of synchronous sequential circuit all the flip flops there is a common flip flop to all the common clock pulse to all provided to all the flip flops. This means here there are number of input, then there is a combinational circuit, there are number of flip flops here and all the flip flops provided a common clock pulse. Again there is a combinational circuit and there are m number of outputs. The operation of a synchronous sequential circuit are determined by the clock pulse as well as some other inputs, but it mainly depends on the clock. When clock pulse is high, then only circuit behaves, otherwise not. But in case of asynchronous, this is a block diagram of a synchronous sequential circuit. Here the some delay element or some past output are connected in the form of feedback and these are as a delay. So, here there are m in case of asynchronous sequential circuit there are n number of input, there are m number of outputs. Here k excitation variables are connected in the form of delay memory. Delay is also a short form of short memory, means only short duration of the time the element is available in a memory. So, this means that is delay, and here based on this delay the final outputs whatever the value of outputs and whatever the value of next states that are generated. So, this is the difference between a synchronous and asynchronous. Here there is no clock pulse, but here there is a clock pulse and that is common clock pulse is provided to all the flip flop in case of synchronous sequential circuit. Now, we discuss about storage element. Latch versus, generally there are two elements which are used for, generally both latch and flip flops are used to store a single bit of information, and the storage element that operate with signal label is known as latch. This is what is the signal label? The storage element that operates with a signal label is known as a latch, and the storage element controlled by a clock transition is known as a flip flop. Here what is, suppose this is a clock, what happens, what is signal label, or that means we can say that the latch is a label trigger while flip flops are edge triggered. Simply here this is a, these are means latch is active only on this time duration, either this time duration or latch is active when this is low. means when clock is only low. This either this or this or this or this, means just like as here we discuss about enable input. When enable input is 1, some of the circuit which when enable input is 0, then circuit behaves. When enable input is 1, then circuit is disabled. So simply either sequential circuit as a label triggered, means the sequential circuit either works when the label value is 1, means that is enable input is assigned as 1, or only the input is assigned as a 0 here. Then that is why it is known as a signal label, that operate with a signal label, means we can also say that the latch are label triggered. This is nothing but a means when the value of label is 1, that is label trigger. The memory element used in clock sequential circuit are called, this means when clock is used, means when let us suppose the same clock is here and circuit is functional. What happens here? Circuit is functional either as a leading edge, this is a falling edge, and then again leading edge. This is known as one complete cycle of clock. Then again start from here leading edge, this is a falling edge, this is again leading edge, this is another complete cycle of a clock. This is again here leading edge, falling edge, this is again here leading edge, this is another complete cycle of clocks, and so on. So this means suppose there are 3, this is one clock cycle, this is second clock cycle, this is a third clock cycle. Now what happens here? So this means this either whatever the value change, once the clock is high, then whatever we change in the input, it is not reflected until the second clock begins. This means the sequential circuit means flip flops behave like as a when the clock pulse is high, then the flip flop circuits behave, and it depends on the clock pulse. So here flip flops or latches are binary cell capable of storing single bit information. Both are used for storing a single bit information, and that is known as here, that is known as edge triggered. That is known, means that start functioning either from a leading edge or from a falling edge. When suppose the circuit behaves in a falling edge, then it clock is completed like this way. Similarly, for falling edge start from here, then another clock cycle is this, and so on. Binary information can enter into flip flops in a variety of ways, which gives rise to different types of. So there are different ways of inserting or entering information into a flip flops. That is why there are different categories of flip flops are there, and major difference among various flip flops are in the number of inputs they possess and in manner in which the input affects the binary cell. That is the major difference between various flip flops, like as whether SR flip flop or JK flip flop or D type flip flop or T type flip flop. The difference is what? The number of inputs and how they process and in manner in which the input affects the binary cell, and depending on the types of flip flop, each flip flop either has 2 or 1 inputs and 2 outputs. Each of the flip flop have 2 outputs, and these 2 outputs are writing as Q and its complement. And the flip flop have some flip flop like D and T flip flop have only a single, has only a single input, and like JK and SR flip flop has a 2 inputs, but the output of each flip flop is same, that provides a 2 output Q and its complement. Now what is the meaning of clock in a sequential circuit? Generally the meaning of clock is nothing but a signal that goes from low to high and again low and repeat the same process. Here the clock is what? Low, simply here this is a clock. Clock goes from low means 0 to 1 and again 1 to 0, then again 1, 0, 1, 0 and same. This process means first clock goes from 0 to 1, then again 1 to means low to high, high to low, and then high, then low, then the same process repeated again and again. And it is a signal, we can say that here Clock is a signal that having a duty cycle of 50%. Means duty cycle, what is the meaning of duty cycle? This is a one clock period, this is a one clock period, this is a another clock period, clock completed one cycle here, second cycle here. This means 50% of the time clock is high and 50% of the time clock is low. So, here that is why we can say that clock is a signal that having a duty cycle of 50% means the clock time for low is equal to the clock time for high. That means here, because in every clock pulse 50% time clock is high and 50% time clock is low, again 50% time clock is high, 50% time, when we can say that this means the clock time for low is same as the clock time for when once we compute all over time, then 50% of the time clock is low and 50% of the time clock is high, and here the edges are instant at which the clock signal change from 0 to 1 or 1 to 0. That means there is a, we already discussed leading edge, falling edge, means when clock signal change from 1 to 0, that is known as a leading. Clock signal change from 0 to 1, not a 0 to 1, that is known as what? Clock signal change from 0 to 1, that is, this is like here the 0 to 1 clock signal, this is known as a leading edge, and falling edge when clock signal change from 1 to 0, not a 0 to 1 to 0, that are known as a falling edge. This is here the clock signal change from, and this simply this is nothing but a one clock cycle. Duty cycle is what? Duty cycle is nothing but a ratio between clock signal high divided by total time. So, when we compute the duty cycle, suppose the clock is here, suppose this is a clock, how many duty times here? Here the clock is rising edge, rising edge, rising edge, and again suppose this is a rising edge. What is the, this is a one clock cycle, this is another clock cycle of, this is another clock cycle, and this is another clock cycle. There are 4 clock cycles are there. So, clock signal high, how many cycle? Clock signal duty cycle is a clock signal high divided by total time, means how many times clock signal is high. So, here clock signal total 4 clocks are there, this means 2 divided by 4. This means that is 1 by 2, and we can say that it is a 50% of duty cycle. Clock signal have a 50% of duty cycle, and duty cycle is nothing but a ratio between when the clock is high divided by the total time. And when we talk about a frequency, how we can speed up the sequential circuit, here there is a frequency is nothing but a frequency is proportional to 1 divided by clock time. 1 divided means when the clock time is what? When the clock time is decreases, then we speed up the sequential circuit, means the frequency is high. When clock time is increases, then frequency is low, means circuit is slow. The frequency of sequential circuit is directly proportional to 1 by clock cycle, that is named as a T. Triggering methods in a sequential circuit, generally the states of the flip flops switch by momentary change in their input signals, and these momentary change is called trigger, and the transition it arises is said to triggering of the flip flop. Means what is the meaning of triggering? Triggering is nothing but change the transition of memory element, when the transition change from 1 to 0 or 0 to 1. There are 2 type of triggering, one is the level triggering and another one is the edge triggering. What is the meaning of level triggering here? Suppose this is a clock pulse, suppose this is a clock pulse here. Level triggering means when this is a label, means either label 0 or this is either label 1, circuit behaves when either label 1 or 0. But what is here? Suppose this is a clock pulse, this is a clock pulse. What is here? This is known as a rising edge, this is known as a falling edge, this is known as a rising edge, this is known as a falling edge, and so on. So, here what happens? Label triggering is based, generally this is label means either the circuit is function when the enable means label is 1 or the circuit is function when label is 0, but not functioning in both label. But here this is different in case of edge triggering flip flop. Here this is based on detecting a sharp edge in the input signal. So, this means the circuit is function either at a rising edge or at a falling edge. Suppose the circuit start functioning start from here, then once the circuit is, suppose the output is here, and then once clock is high, the output is suppose high, this is suppose output and this is high, then whatever the change in input, it is high up to second rising when next rising edge occurs, and then suppose after that this is low, then this is low when second rising is here up to this, and again suppose this one is high, then this one is high up to here, and then suppose low and so on. So, here this change means it not means here this is means the clock it goes from 0 to 1, but the inputs not affected there, inputs not affected there. Similarly, clock again goes from 1 to 0 means low to high, but the inputs remain same here in case. So, that is known as a label triggering, means once either clock means the circuit start functioning either as a rising edge or start functioning, suppose the some output 1 and output 2 start functioning from a falling edge, suppose this, then once whatever the input change occurs during that, after that the input change reflected only when the clock becomes next falling edge occurs, then again and again. So, this process is called as edge triggering, means the output signal is activated when the trigger edge is detected and change the states. Positive, there are two type of edge triggering, positive edge triggering, negative means when the circuit is functional on a leading edge, that is known as, this is what positive edge, means when the edge goes from 0 to 1, that is known as a positive, and this is known as negative. This is known as, and these are what? This is a label triggering, generally label triggerings, latches are label triggered, and flip flops are a synchronous sequential circuit which are edge triggered. So, generally first we start a SR latch. SR latch means set, SR simply represents a set reset latch. Set reset latch means this is a latch, we already know what is latch. Latch is a basic storage element which is capable of storing single bit of information, and how generally we know that which is the basic building block of latch. Gates are the basic building block of latch, and when we design a flip flop, generally we use a latch to design a flip flop, but for designing a latch we use a logic gates, and here for building a SR latch, there is a there are two type, either two cross coupled NAND logic gates are used or two cross coupled NOR logic gates are used to design latch. So, similarly, like here this is a latch, two cross coupled NOR gate are used, means cross coupled means output of first NOR gate is provided as input to second NOR, one of the input to second NOR gate, and similarly output of second NOR gate is provided as a input to the second input to the first NOR gate. This is what, and another in the first input is provided for first NOR gate input is provided as R, and for second input is provided as S. So, this is known as a FIN simply. And what is happens, what will be the output? There are two outputs which are, first output is Q, then second is its complemented form, nothing different. First output is Q, second is, so simply the output is what? We can say that in case of each flip flop there are two outputs are generated, one is the, suppose the output variable Y, then another is its complement, or suppose one is Q, then another one is its complement Q complement. So, this is a SR latch made up of two cross coupled NOR gate, and similarly for finding a SR latch, This is SR latch using 2 NOR gate. Another way of designing a latch is what? We use a 2 cross coupled NAND gate and we design it here 2 cross coupled NAND gate. Cross coupled means output of first output of first, that is a Q suppose, and this is what? Q complement. This is what? This is simply provided as here, that is a R, this is S, and second input of this gate is connected to form of feedback path, means that is the output of second NAND gate, and second input of second NAND gate is what? That is OR. And here this is a SR latch using 2 NAND gate. Now the question is how we generates the output value, because in case of latch the output is determined based on their present input. What are the present input? There are 2 present input that are named as S and R, similarly S and R, and what is the previous state value, that is Q, because that is simply a Q complement, whatever stored here its complement stored as in this output. How we generate? What happened here? Suppose in this case first when SR latch made using 2 cross coupled NOR gate, and suppose what is the value of, suppose the value of S is what? 0 and R is 0. Suppose both are 0 0. What happens? And let us take, suppose first we consider the case, suppose we consider the case when S is equal to 1 and R is equal to 0, means S is equal to 1 and R, S is set, suppose R is, S is 1 and R is equal to 0, then what happens here? What will be the output? And when S is equal to 0, S is equal to 1 means this input is 1, and when any one of the input is 1 in case of NOR gate, then what will be their output? The output is 0, whatever, it not depends on the second input. This means immediately this output is generated because this not beats the value of other input when the value of one of the input of NOR gate, because in case of OR gate if any one of the input of OR gate becomes 1, then output of that OR gate becomes 1. Similarly, NOR is just opposite of OR, just perform a inverse operation of a OR, means once any one of the input is 1, the output is 0, and when all the inputs are 0 0, then only the output is 1. Here then what happened here? R is equal to what? R, the value of R is equal to 0, then second input of this NOR gate is what? The second output, means that is a Q complement, and the value of Q complement is what? That is 0, and what happens here? This is 0 0 means that is 1. This is 1. What happens when suppose this here this is 0 means the previous state whatever happens, because this is what? This is 0 means this is already stored as a 1, and that is after that, after performing these operations, the Q is also 1. What happens means here when S is equal to 1, R is equal to 0, if Q is equal to 1, what happens? Q is equal to 1 means that is the next state, and previous state of Q is also here previous means Q next and Q previous is also 1. What happens when S is equal to 1? When S is equal to 1, R is equal to 0 and Q previous is equal to 0. Q previous is equal to 0. Then what is Q next? Here that is output is what? Q next. Another one is a Q next complement. So here what happens when S is equal to 1, S is equal to 1, R is equal to 0, this means here in this case S is equal to 1, when any one of the input, this means this becomes 0, and here this 0 and 0, that is 1, means the output of next state in that particular condition, the output of next state not depends on the previous state, but depends on the input S and R. Means when input S and R are 0, S is 1, R is 0, then whatever the value of previous state or previously stored element QP, the next state is always 1. So, here we can say that simply when S is equal to S, suppose here we have to write S R, then simply this is Q previous and this is Q next. Simply when the value of this is 1, R is 0, whatever the value QP is 0, the output next is also 1, next state. When this is 1, 0, QP is 1, what will be the next state, that is 1. Means it whatever the value of QP, that is always 1. What happens next now? What is the, suppose the again the this is 0 0. What happens in the case of 0 when both S and R are 0 0? Here in case of NOR gate both S and R are 0 0, then we will find the value, because in case when this R is 0, we can the output of NOR gate depends on the second input, and here S is 0, this means the output also depends on the second input. Then we will find what is the previous state. Here previous stored value is 0, and in the next case when S are 0 0 and previous state value is 1. So, when S are 0 0 and previous state is here stored as a 0, this is 0, this is 0 and previous state is 0, this means this 0 0, this means this is 1. And here when 1 and 0 are goes, then one of the input is 1, this means this becomes high. This becomes high, this becomes again, this is what RH 0, here S is 0 and then Q is 0, this means this becomes 0 0, and what will be the value of NOR gate in case of 0 0, that is 1, and this is 1 and this is what, then once again this is 0. This means whatever the value of previous state, this is also the value of next state. What happens when this is 1, this is 0, this is 1, suppose previous stored value is here, that is 1, then what will be the next state? Here S is equal to 0, R is equal to 0 and previous state QP, that is equal to 1. Here S is equal to 0, QP is what? That is 1, because when S one of the input is 0, then the output of NOR gate depends on other input. What will be the other input? QP, other input is QP, that is 1 here. So, when 1 0, one of the input is 1, this means what? That goes to 0. So, here what happens? The Q complement, this particular output is 0, and again our objective is to determine the value of Q. Then once this is what? This is 0, this means what happens? 0 and R is also 0, 0 0, what will be the value? That is 1. This means next state value. So, here we can say that this is a hold state, means whatever the value of previous, in that case whatever the value of previous state QP, the same value, this means that is also same as QP. That is why it holds the same value that are already stored in the memory when the value of SR is equal to 0 0. What happens? Suppose the value of S is 0 and R is 1. Then suppose the QP is 0. Here one of the, again here we see that one of the input of this is 0, one of the input of this is 0, another is 1. Here the value of R is 1. R is 1 means once the input of any NOR gate is 1, here the value of R is 1. This means whatever the value of second second input, the output is always what? The output is always 0. And once 0 is here, this means whatever this 0 is coming here and the value of S is what? The value of S is also 0, 0 0 means this goes to 1. So, here this is 0, this is complemented from 1, this means the output is what? Here the next state value is 0. What happens? 0, 1 and the next state is 1. Suppose here R is 1, this means whatever the value of previous state, the next state value is what? The next state value is again this is 1, this means the next state value is 0, and 0 is coming, again this is 1, this means this is whatever the value of previous state, the output next state value is always 0. Next is, this is known as a reset condition, this is reset, means whatever the value of previously stored, after that, after modification, the next state value are 0 0. In that case, that is a set state, means when the input S is equal to 1, R is equal to 0, the SR latch is known as a set state. When S is equal to 0, R is equal to 0, the SR latch is in hold state, means that holds the previously stored value, and when S is equal to 0, R is equal to 1, then whatever the value of previous state, the next state values are always 0, that is the condition of reset. Now the question is what happens when both values are 1 1, both values are 1 1, and whatever the previous state, suppose the previous state is 0 or 1, previous state. So when both input are 1 1, suppose this is 1, this is 1, and we know that in case of NOR gate, when any one of the input of NOR gate is 1, the output are 0 0, both output are 0, this is 0, and we know that the complement, if the variable value is 0, its complement value is 1, and if variable value is 1, its complement value is 0, and here these two outputs, one represents a Q, another represents their complement, and here Q and Q complement both having a same value 0, this means this is a invalid situation. So this is invalid input. This is a invalid, means this is not working in case when the value of R and S both are 1 1. So this is SR latch and their truth table, and in short form this truth table is written as what? Here the truth table is truth table of SR latch. Truth table of SR latch is what? Truth table of SR latch, when input is what? S R, output is what? Previous state is also input, and then we generate a next state Qt plus 1, or that is a Qp, this is known as Qn. What is here? 0 0, suppose this value is whatever the value of Qt, means that is 0, here we can say that in case of 0 0, whatever the value of Qp, that is either 0 or 1, the next state value is same as here 0 1, whatever the value of Qp, means either 0 or 1, 0 1, this is case, means that is always reset, the value is always 0. Here 1 0, whatever the value of Qp, 1 0, whatever the value of Qp, this is always set state, that is 1, and similarly 1 1, whatever the value of Qp, this is a invalid. Invalid input combination because Q and Q complement both goes to 1, and it is not possible that the variable and its complement at the same time having a same value. Now question is, what are the different types of latches? So generally this is, and another important point is this, when we design a SR latch by using a two cross coupled NOR gate like this, then simply S input is provided to the second NOR gate and R input is provided as a first input of first NOR gate. This is important point, and here corresponding to R we take a Q as a output and corresponding to S Q complement. But what happens when we design the latch by using a NAND gate, and for making the similarity in a truth table, what happens here, when S is provided, means first NAND gate, these are the NAND gate, first NAND gate, the input S is provided, means the output Q of that NAND gate in which first input is supplied as a S, and complement is taken from the NAND gate in which R is supplied as a input. What is transparent latch here? Transparent latch output change immediately when inputs change. Here we cannot, in case of this is a transparent latch, this is a transparent latch, this is a transparent latch, means here output change occurs when anyone incidentally or accidentally change the value of R input value R and S, then the output change occurs in this case. But what happens when we simply suppose here and this particular input is taken as a enable input and another input is taken as yes, and here the second input is taken as R, then what happens here, or simply we design it clearly. Suppose this is a 2 input NAND gate, this is a 2 input NAND gate, and second input, this is a 2 cross coupled latch by using a NAND gate, and here again we use a NAND gate here, and this again this there is a common input, and this is what yes and this is R. Here what happens in a gated latch, this is a gated latch, this is nothing but a gated latch, because here the output change predicted only when this particular input is high. The value of this means the output change means when each enable input is high, then output change, when input is changed then output immediately change, but when enable input is low, whatever we have to perform the output does not remain same. So, that is the difference between a gated latch and a transparent latch. Here latch output change depends on the enable input E, and when enable input is active, then output change depends on the input, otherwise not. So, here this is the difference between a transparent latch. Transparent latch, there is no common input, like there is no enable type of input is there, and in case of gated latch there is a enable input is given to control the behavior of a circuit, but this enable input is not known as a clock pulse. This is a label triggered, means once the input is high then only the circuit behaves, otherwise. What is flip flops now? That is also a memory element, but there is a difference. Memory element used in clock sequential circuit are called a flip flop. When we use a concept like as here, suppose this is what, suppose this is a one input yes and this is another input R, and this is what Q is taken as here and Q complement is taken from here, this is SR latch. SR latch, that is SR latch when simply S is Q is taken against S, this means SR latch made up of 2 cross coupled NAND gate, and when here there is no clock input, this means this is a latch, and when we provide a clock input that in the to this flip flop, this means this is working either at a positive edge or either as a leading edge, and the input change reflected only when arriving of next clock pulse. Once the clock pulse arrives and whatever the value of output, and during a clock if input change occurs, the output or next state value of the flip flop does not change in case of flip flop. Once the clock again next clock is started, then the change reflected. So, this is the difference between flip flop, and here flip flop is also a binary cell, and flip flop is capable of storing 1 bit information just like as a latch, but it is a controlled behavior is based on a clock pulse, and in case of latch either there is no control behavior or control, it controlled by a enable input. Enable input is different from a flip flop. Each flip flop has a 2 outputs, one for normal value and another one is for complemented value. Based on the number of inputs flip flop possesses and the manner in which the input affects the binary cell, flip flops are categorized into 4 different category. One is a SR flip flop, that is known as a set reset flip flop. Another is a JK flip flop, that is known as a Jack Kelly flip flop. This is named in a name of scientist. Another one is the toggle flip flop, and another one is the D flip flop. Flip flops are used in the designing of, why we use the flip flops? Generally flip flops are used in designing of sequential circuit like counter, shift register, memory, etc. And also design a synchronous counter, asynchronous counter, etc. We use a flip flop. So this is something about flip flops. And next, what is the meaning of SR flip flop? Generally SR flip flop has a 2 input. This is a graphical symbol. This is a graphical symbol of SR flip flop, and that is a clock. Because it is a flip flop, this means this is a synchronous sequential circuit and there is a clock, means this is working only and only on arriving of clock, either positive edge clock or negative edge clock. So there is a, these are 3 inputs, 1, 2 are the inputs of the flip flop that are named as R and S, and here this is a Q and Q come. Once Q is taken, means output Q is taken against a input value R, this means here this is a 2 flip flop designed from 2 cross coupled NOR gate, and once the input Q is taken from corresponding S, this means the flip flop is designed by using a 2 cross coupled NAND gate. SR flip flop has 2 input, that is known as set and reset, and when the input is set and reset, set means the value of input is 1 and reset means R is equal to 0, and set basically indicates set the flip flop, which means output 1, and indicates resetting the flip flop when means the output 0. Set means that is used for set a flip flop, means making a output 1. So what is the set condition? Just like as a less, the output of SR flip flop is same, output table or truth table of SR flip flop is same, and B design, only the difference is here when we use a 2 cross coupled NOR gate. This is what? This is R and this is S, Q, Q complement, and here what happens here when we design, suppose this is a R star, S star, and this same input is here by connecting a AND gate. What is first input is provided as R, second is input is provided as second input of first, and first input of this gate is connected as a, and this is what? This is nothing but a clock pulse, and that is common in both gate, and this is another input that is named as a S. This is what? Flip flop, SR flip flop, here there is a clock pulse. What happens here? When clock pulse means this flip flop is working when clock pulse value is 1. When clock pulse value is 0, this means it not works. Truth table of SR flip flop, here there is no need of writing a clock pulse, because it always works when clock pulse is high, either the clock pulse is positive edge triggered or negative edge triggered. We always we already discussed about triggering of flip flop in a previous lectures. Here truth table of SR flip flop, there are 2 input S, R, and Q, Q previous is the input, and here we generate a Q next as a output. Next state, QP means previous stored value. What happens here? 0, 0, whatever the value of previous state, that is QP means QP is either 0 or 1, this next state is same, that is a hold state, that is also same as QP. What happens in 0, 1, QP is suppose whatever the value of QP, this is always 0, that is a reset. Whatever the value of QP, this is 1, this means that is a set state, and 1, 1, this means whatever the value of QP, this is invalid. This is known as invalid state, because in that situation Q and Q complement both becomes 1 at the same time, and it is a unpredictable situation. So this is truth table of SR flip flop. In the next class we will discuss about how we derive a excitation table from the truth table of SR flip flop, and how we generate a characteristic equation of SR flip flop, and we also discuss the JK flip flop, T flip flop, D flip flop, and so on in the next class. Thank you very much.